Jeff.
All your friends. Yeah. Like we used
Oh
to like.
man, technology. Okay. There we go. Cool. All right. Let's take a look here. So we should take a break. So those are the numbers I get for those columns. Is that cool? That should look familiar, right? Maybe? No? All right. Now, do you remember, I don't know if you guys did this, you could do the list thing. Remember the list? You go to second stat, and then you want to do math on the list. You want to sum up the list. So there's the sum of the third list, 45.89. So that's the mean. Okay. And then I could just hit second enter and make this into L4. Bam. So that's those two things right there. The mean is the one I get directly. This guy is used to discover the variance. It's not the variance itself, right? This first question will basically be almost always the same answer. In this case, what do the probabilities add up to be? 1. If they didn't, like some teacher might do to you, maybe that teacher already told you he was going to do it. If they added to be 0.999, you would say this. If you just say this, I'm like, are they supposed to? I'm trying to see from you, do you know what it's supposed to be? And that's approximately 1, so that's fine, because it's supposed to be 1, and it's close enough. Okay, I like it. All right. So basically just told you that answer on the test. We'll see if anybody does it right. Okay. And then I get, the other thing I gotta say is this. Somehow, right? So you can either say it all in words, you can, just like you did on the other side, you can say they all add up to 1, all the probabilities add up to 1, and each probability is, you can use words there, it's fine. Or you can use math symbols, which is a quicker way to say it, because math kicks ass. You would say that. And then this one is really just trying to make sure you can read this correctly. This column is two things at the same time. It's the percentage that said this, and it's the probability that somebody said this. So what's the probability that somebody is picked that thinks they'll be at least 25? So whenever you see that at least, when you go to SeaWorld, or you go to, where else? You go to freaking United, whatever the shit, you want to go ride a ride. And you got to be at least this tall to get on the ride. I still kind of remember going, the year that I went, I could finally ride this one ride, and it was shut down. I went with my grandparents. And I'm like, I'm finally tall enough. And, oh, life sucks. I'll never forget that. But at least this tall means you got to be this tall or more. So at least always means that or more. Okay, I like it. So at least 25 is going to be all these. With me? Now please let this make sense. If all of these add up to be 1, 1 minus this has to be all this. Right? What's 5? Let's do it. What's 3 plus 7? What's 10 minus 3? What's 10 minus 7? So if you get a total of stuff, the total minus one chunk of shit is the other chunk of shit. That's really a more general thing about the at least one thing. So at least 25, what's the only thing it leaves out? 21. In my data, it's the only thing it leaves out. So 1 minus this is the probability greater than that, or at least this, right? It's everything else. Or just add all these up. There's not that many of them. Either way you do it, you should get 96%. Yes, ma'am.
I have a question on L4. When I in the individual, it did not equal what you had.
So you got L3 okay?
Yeah,
Okay.
and I got all the numbers in L4 correct, but when I hand typed all these in, I came.
Oh, to sum them up? You didn't get the same sum. All right. Because all it takes is one decimal forgotten or in the wrong place, or 1, 2 that looks like a 7. That's all it takes. So you did 17.64, right? Plus, and then the rest. So it's impossible for it to be. Did anybody else get not 2410.89? What'd you get?
It's 2,410.94.
Yeah, that's right.
Oh, okay. So maybe it's my fault. Let's see. Did I leave something out? Did I mistype something? It's always possible. 50, 40, 25, 21. That looks good. Oops.
Your numbers are still the same.
Yeah, your numbers are the same.
I know.
Hand typed them in the calculator, and came up with a different sum for L4.
Oh, because this is rounded. See, 1225.25. So if you use 1225.3, yeah, you're going to get a larger answer. And this one was actually, well, that one actually was that. So yeah. If you round, the answer is going to be different. That's why I try to push you guys to doing that in the calculator for 2 reasons. One, this isn't Math 88. I'm not testing to make sure you can square shit. Right? So the calculator can do that for you. And secondly, if you do it in the calculator, it doesn't round. It shows 1225.3, but did you see how it was like, it's really this? So it has the right value in there. So when you tell it to add that up, it doesn't round any of them. And the earlier you round in a problem, the more off your answer will be. So that's the advantage that using the calculator for basic math does. It doesn't round. It's built in. Okay, I like it. Is that cool?
So do we have
Sort of. I wouldn't kill you on that though, but I mean that's why I'm trying to push you to this, because if you do it by hand, you can't round until the end. So you got to really be careful about what that really is. Is that okay? What I just said? All
I
right.
was gonna ask that if we had added it up, because it's different, you set it up in hand as opposed to
Technically, yes. Will I unleash a flood of ink on that? No. I mean, that's, you understand what I'm saying? Yeah. It's just the one huge lesson I want you to learn is don't round too early. In fact, don't round at all until the end. The one place I let you round, because it's just going to be everywhere and get all messy, is standard deviation. We use that sucker all over the place. So by rounding, I just kind of eliminate the need for you to try to use memory things and all that stuff to carry the whole thing. Are you guys kind of with me a little bit? Okay, maybe.
I was just wondering, what did you do again to get the sum of that entire list?
Oh, so what I did was, if you go to list, right above stat, that's where you can go to math, sum. And I'll show you another way to do this. If you don't like this other way, see, then I can sum up L3. And then if I hit second enter, it brings up the last thing I did, and I just put L4 in there instead. Kick ass. Or, let me show you another way. You don't have to do this if you don't want to, trust me. Don't I want to add up both columns? I want to get L3 and L4, both the sums. So if I go to stat, calculate 2 variable stats. And again, you don't have to do this. And I tell it L3 and L4. It's going to give me a buttload of stuff. It just is. And that is a technical measurement. But all I care about is the sum of the x's. That's the sum of the stuff in L3. And look, it's got 2 variables now. I got 2 lists. So it's going to call the other one y. Isn't that crazy? And the sum of y is that. All this other stuff doesn't mean shit to me. All I want is the sum. So that's a little bit quicker way to get it, as long as you know what to pay attention to. Okay, maybe. Okay.
I got your answer exactly when I did the sum of that.
There you go. Kickins the acid. I like it. Okay. Now, so the mean I got directly. What do I put here for the standard deviation, the variance? What do I put right there? Yeah. That sucker there. Minus 45.89 squared. Good, that's the most forgotten little dude. Poor little dude. 2410.89 minus 45.89 squared, and you get 304.9979. And then I want to take the square root of that. That answer button is so awesome. And then that's going to mean the standard deviation is 17.464. If you want to go more places, you can. Just don't go less. Loose points that the guys have looked at. Okay. So in the middle, now this same question, I'm gonna ask this question so many freaking times. The difference on this problem, let me show you the difference in a minute. What always goes in the middle? The mean. That's our measure of center that we accepted to be the most useful generally. So I'm going to put the 45.89 here. But take one step up. 63.35, blah, blah, blah. And if I take one step down, blah, blah, blah. Okay. So what do I catch in here? Do I catch the 25s? No, because they're out there. Do I catch the 40s? Yes. 40s are caught. Do I catch the 50s? Yes. 50s are caught. Do I catch the 65s? Shit. All right. So I caught all the 40s. What percentage of the kids said this? And I caught all the 50s. What percentage said that? So what total percent of the kids did I just catch? 41%. You can't just say 2 out of 1, 2, 3, 4, 5. It's 2 out of 6. You can't do that because these are not all equally represented. They're not all equally likely. You just add the percentages up directly. Okay. We are ready for that break. One last question. This is the first place you got to worry about this fact. 1,200 total kids. What percentage think they'll retire before 65? Yeah, if you add all these up before 65 are these, you get 69% of 1,200, which is? Do it again, sorry. 828 kids think they'll retire before 65. They're 12 to 16, so that's more than likely wrong. Yeah, keep pushing that retirement age up. All right, any questions before we take a break? All right, so let's take a break. Come back at, I don't know. Come back at 10:35.